So in the previous part we have seen some of the variable selection techniques within the multiple imputation. One point about those methods is that especially the majority rule has been around within the Bootstrap for a while, and the majority rule is also used in the context of multiple imputation. So if you are using Bootstrap, do not confuse with the multiple imputation rule, because they can lead to very different covariate list out of the stepwise. Here is an example where the Bootstrap was used out of 200 Bootstrap sample. So what I did is that I just generated one dataset and then I Bootstrap 200 times by taking with replacement sampling, and out of those this is the result, which is not very different than what we have seen in here, 6, 9 and 2. In here out of 200 we are seeing this was forced, and this was out of 200, this is also out of 200. The point that I'm trying to make is that both are majority rules based on Bootstrap as well as the multiple imputation, but they can lead to different conclusion about the variables. Alright, so the last point about the multiple imputation I want to make is about the convergence. So remember, there was this max IT equal to 5, and when you plot this you should see something very similar. If something is jumping out and looking out of ordinary, that is probably an issue. So in that case, generally it is a very good idea to increase the number of the iterations and then try to see whether there is anything that is jumping out totally from all of the others. So by inspecting these visually, it does not look like something is going horribly wrong in here or have a pattern in here. Alright, so that was for convergence. For diagnostic, it is a very good idea to compare the observed value versus the imputed data. So if you look at the red line and the blue line here, those are almost superimposed, and they do not really look very different to me in terms of the pattern, but obviously in here as well you can increase the number of imputed data, and you can see even after that the superimposing patterns are relatively similar. You can also try to draw a box plot. So this is for only 10 iterations, and you can see this is the observed and these are the imputed, and you can see some of those imputed data are slightly different than each other, but within the box plot you can see they are almost within the maximum and minimum bound. But if you are looking at the quartiles in here, then it is looking a bit problematic. So maybe think about how to improve the prediction model for BMI maybe. For these, say for example, this one looks a bit weird, so it is also again very good idea to increase the imputation. Say for example, this is for I think 50, and out of those 50, even though there you can see there are some outliers here and there. So maybe even for age and for BMI you are still seeing some sort of pattern, right? So this is more sort of what it usually looks like when there are not much problem, I guess. This is observed and these are the imputed, but these have some pattern, and maybe with a better imputation model this can go away. Alright, so again the reference is this book, Flexible Imputation of Missing Data,